This problem from linear programming problem, and it is of simplex method, and the problem is solve the following LPP by simplex method. The problem is given here. Write its dual. Also write the optimal solution of the dual from the optimal table of the given problem. Okay. Now we first write the given problem in standard form. Since there be two constants only and both of them are less equal to type, so we introduce two slack variables, right? And slack variables are x4 and x5. So the standard form of LPP is given by max z, this is equal to 2x1 minus 4x2 plus 5x3 plus 0x4 plus 0x5. This is the objective function, and subject to condition are given by x1 plus 4x2 minus 2x3 plus x4 plus 0x5. This is equal to 2, and second one is minus x1 plus 2x2 plus 3x3 plus 0x4 plus x5. This is equal to 1. With xj greater equal to 0, for j this is equal to 1, 2, 3, 4, 5. Okay, 5 variables are there. Now to solve it by simplex method, we draw a simplex table first. Then we start to solve by simplex method. We fill the simplex table starting from the basis column, that is B. Here two bases are, first basis is 1 0 and second basis is 0 1. This is corresponding to x4 and x5. Okay, so the vectors are a4 and a5. We write here a4 and a5, and the corresponding variable are x4 and x5. Okay, and now we write the objective function or the cost coefficient of objective function. This is given by 2 minus 4, this is 5, this is 0, and this is 0. Okay, and here we write 1 0 0 1, the corresponding standard basis 1 0 0 1. And now here we write the cost corresponding to a4 and a5, which are given by 0, both 0 and 0. Okay, now we fill the remaining table. 1 minus 1, sorry, this is not 1 minus 1, second is 4 2 and 4 2, and third column is minus 2 and 3. Okay, and the column of B is given by B vector, this is 2 1, right? 2 1. Now we calculate the net evaluation Zj minus Cj. Zj minus Cj is given by, we start from here, 0 into 1 plus 0 into minus 1, this is 0 minus 2, so this is minus 2. 0 into 4 plus 0 into 2, this is 0, minus of minus 4, this is plus 4, and obviously this is minus 5, this is 0, and this is 0. Okay, so most negative net evaluation is this. So we say that here A3 vector is the entering vector or incoming vector. Here we write A3 incoming. Okay, now we calculate the mean ratio. How to calculate mean ratio? Calculate mean ratio by 2 divide minus 2. But this element is negative, so we cannot calculate this mean ratio. So we only calculate 1 by 3, and since there is only one mean ratio, so this is minimum. Okay, and this column is key column and this row is key row, so this is the key element, and key row indicate that a5 is outgoing vector. Here we write a5 outgoing. Okay, so we pass to the next simplex table. We draw the next simplex table as. Now we fill the next simplex table starting from the basis column also. Here A5 is replaced by A3 because A3 is incoming and A5 is outgoing. Okay, so we write here A3 in place of A5 and A4 remains same, A4, and corresponding variables are X4 and X3, and clearly the corresponding cost coefficient, this is 0, and corresponding cost coefficient of A3 is given by 5 here. Okay, now we fill the cost coefficient column, row. This is 2, -4, 5, 0, 0. Okay, so now we convert the key element, this is 3 into 1. So we have to operate second row. Here we write the operation of second row, R2 dash, this is equal to 1 by 3 into R2, and getting the result as this is 1, this is 0, this is 1/3, this is 2/3, this is given by -1/3, and this is 1/3. Okay, now we make it into 0. So we make the operation R1 dash, this is equal to R1 plus 2 into R2 dash. This is new second row. Okay, and here we write this is 0. Now we start from this element, this is 2 plus this is given by 2 into 1/3. Okay, so we get this is 5 by 3. Sorry, this is 8 by 3. Okay, this is 8 by 3. Now this element is given by 1 minus 2 by 3 because we multiply with 2, so this is 2 by 3, and this is given by 1 by 3. Okay, and for this column or this element we write here 4 plus 2 into, this is 2 by 3, so this is 12 plus 4 by 3, this is 16 by 3, and this is clearly 1, and this becomes 0 plus 2 by 3, this is 2 by 3, right? And this is the table. Now we calculate Zj minus Cj, that is the net evaluation. Net evaluation is given by, this is 5 into 1/3, this is 5 into -1/3 plus 0 into 1/3 minus 2. So we calculate here minus 5 by 3 minus 2. So we get this is -5 minus 6 by 3. So this is minus 11 by 3. Right? This is minus 11 by 3. And this is given by 10 by 3 plus 4. 10 by 3 plus 4. This is given by 22 by 3. Right? 22 by 3. And clearly this is 0, this is 0, and this is 5 by 3. Okay, and clearly this is the negative net evaluation, only negative net evaluation. So this column must be key column. Again we find out the mean ratio. Here only one positive element in this column, so mean ratio is obviously 8 by 3 by 1 by 3, and this is given by 8, and this is minimum. Okay, and since this is negative, so we cannot find the mean ratio. Here we indicate a blank sign. Okay, now this mean ratio gives, this is the key row, and since this is key row, so this is key element, right? And this is the key element, so we go to the next table and convert the key element into 1, and this column becomes the new standard basis of type 1 0. Okay, now we draw the next table or next simplex table. The third simplex table, we start to fill the table from the basis column. Here we write A1 in place of A4 because A4 is outgoing and A1 is incoming. Okay, so A1 and this is A3 as above. A3 and the corresponding variable are x1 and x3. We write corresponding cost of A1 is 2 and A3 is 5, right? And now we convert 1/3 to 1. So we make a operation. Here we write operation, the operation column. Okay, and we make the operation R1 dash, this is equal to 3 R1 because this is 1/3. So we multiply all the element of this row by 3 and it is given by 8. This is 1, this is 16, this is 0, this is 3 and this is obviously 2. Now we convert it into 0. We make the operation as R2 dash, this is equal to R2 plus R1 dash into 1/3. Okay, and we calculate it easily because this is 1/3 and this is minus 1/3. So we add old R1 and old R2. We get easily all the result. This is 0. This is 8 by 3 plus 1 by 3. This is 9 by 3. So 3. This is 16 by 3. This is 2 by 3. So 18 by 3 and this is given by 6. This is 0, this is 1. So this is obviously 1 and this is given by 1 and 0, this is 1 and this is 2 by 3 and this is 1 by 3. So this is 3 by 3, this is also 1. Okay, now we calculate Zj minus Cj and Zj minus Cj is given by, this is 0 and this is 0 because it's a standard basis, and this is given by 32 plus 80, 32 and this is 30. So this is 62. 62 minus 4, this is plus 4. So 66. Here we write 66. This is given by 3 into 2, 6 and 5, 11. And this is 4 and 5, this is 9. Now since all the net evaluation are 0, so we reach at the optimal stage. And now we fill this column or this cell, and this cell gives the answer as 2 into 8, this is 16 plus 5 into 3, this is 15. So this is given by 31. We can also find the optimum value or maximum value 31 by putting x1 equal to 8 and x3 equal to 3 here. x1 equal to 8 and x3 equal to 3 here. This is 16 plus 15 and this is given by 31 and x2 is 0. Okay, we can also find the maximum value from the objective function or original objective function. So we write here optimal solution. Optimal solution is given by x1 this is equal to 8, x2 this is equal to here x2 is not present, so we write x2 equal to 0 and x3 equal to 3 because x1, x2, x3 are only 3 original variable and we no need to write the slack variable x4 and x5. Okay, and we must write also and z max this is equal to 31. This is the solution of the problem by simplex method. Okay, now here we write the dual, that is the next portion of the problem. Here we write the dual of the problem. How to write the dual of the problem? The dual of the problem is given by mean W. This is equal to 2v1 plus 1v2. 2v1 plus 1v2 or only v2. Because here two constant, so we take here two dual variable. First is v1 and second is v2. Okay. Now the constants are given by, this is v1 minus v2, and this is greater equal to type because these constants are less equal to type. So in the dual problem it is greater equal to type, greater equal to, this is c1, so 2, and the second constant is 4v1 plus 2v2 greater equal to minus 4, this is minus 4, and the last constant is minus 2v1 plus 3v2, this is also greater equal to 5, with v1 v2 greater equal to 0. This is the dual of the given problem, that is, this is primal, and it is dual. Okay, now we read the solution of the dual problem, that is this dual problem, from the optimal table of the primal. We say from this table the optimal solution of the dual is given by v1, this is equal to 11, okay, and v2, this is equal to 9. That is from the net evaluation of slack variable of the primal. Okay, and with mean W is given by, we also from here we write, this is 2 into 11 plus 9, this is 22 plus 9, this is equal to 31. Or we say directly mean W, this is equal to mean W, this is equal to max Z, this is equal to 31. We also verify here mean W and max Z, these are same. Okay, and this is the last answer because solution of the dual from the optimal table of the given problem, that is optimal table of the primal problem. Very interesting and important problem of simplex method. Okay, thank you for watching.